By using the Lagrange multiplier method, find the minimum and maximum values of the function fxy equals to 2x minus y minus 1 subject to the constraint x squared plus 2y squared equals to 72. So we have a function fxy equals to 2x minus y minus 1, which subject to the constraint x squared plus 2y squared equals to 72, or we may write down as gxy equals to x squared plus 2y squared minus 72. So let us form the new equation fxy lambda equals to fxy plus lambda gxy. So 2x minus y minus 1 plus lambda times with x squared plus 2y squared minus 72. So let it expand. 2x minus y minus 1 plus lambda x squared plus 2 lambda y squared minus 72 lambda. So the first step, let us find the f sub x, f sub y, and f sub lambda. So let us differentiate 2x with respect to x is 2. Differentiate negative y minus 1 with respect to x is 0. Differentiate lambda x squared with respect to x is 2 lambda x. Differentiate 2 lambda y squared minus 72 lambda with respect to x is 0. F sub y, differentiate 2x with respect to y is 0. Differentiate negative y with respect to y is negative 1. Differentiate negative 1 plus lambda x squared with respect to y is 0. Differentiate 2 lambda y squared with respect to y is 4 lambda y. Differentiate negative 72 lambda is 0. So f lambda, we simply just copy down the function or the constraint x squared plus 2y squared minus 72. So now let's find the value of x, y, and lambda. So let us take a look here. What equation do we have here? We have 2 plus 2 lambda x. We equal it with 0. So 2 plus 2 lambda x equals to 0. And if x become the subject, so we're going to get x equals to, I simplify 2 plus 2 lambda. I think I'm going to make lambda as the subject, not the x. Okay, so lambda equals to, if I simplify, bring the 2 to the right and divide with the 2x here, I'm going to get negative 1 over x, right? Okay, so what I'm going to do next is we have another equation which is negative 1 plus 4 lambda y equals to 0. Okay, so this is the second equation we have here. So I'm going to substitute my lambda into my second equation. Okay, so let's say this is the first equation, this is the second one, so I'm going to substitute into the second equation. So negative 1 plus 4 times negative 1 over x times with the y equals to 0. So let us simplify this. If we bring this negative 1 to the right hand side, we're going to get a positive 1, right? And negative 4y over x equals to 1, and I'm going to get my x equals to negative 4y. So next is I'm going to use this one to substitute into the third equation, which is we're going to equal this with 0. So x squared plus 2y squared minus 72 equals to 0. So let's say this is the fourth equation. So I'm going to substitute my third into my fourth equation. So what we're going to have here, so this negative 4y, if we substitute into the x squared, we're going to get negative 4y squared plus 2y squared equals, minus 72 equals to 0. Expand negative 4y squared, it is 16y squared plus 2y squared minus 72 equals to 0. So 18y squared minus 72 equals to 0. Divide with 18. Right, both sides we're going to get y squared minus 4 equals to 0. We can factorize as y plus 2 times y minus 2 equals to 0. We're going to get two values of y equals to negative 2 or y equals to 2. So since we have two values of y, we're going to find our value of x. So if we have two value of y, means we're going to get two value of x. So let us substitute into 3, okay, the third equation. So if my y equals to negative 2, so what is my x? Substitute into the third equation, negative 4y. So x equals to negative 4 times with negative 2 is positive 8, right? So if y equals to positive 2 now, so x equals to negative 4 times 2 is negative 8, right? Okay, now what we're going to do next is we also need to find the value for lambda. Okay, what is the value for lambda? So let us substitute our x equals to 8 into the first equation here, where we're going to find the lambda for the first point. Okay, lambda equals to negative 1 over x. So substitute into the first equation. So lambda equals to negative 1 over 8, and for y equals to 2, x equals to negative 8, and the lambda is equals to negative 1 over negative 8 is positive 1 over 8, right? Now what are our critical points? Let's write down our critical points first. So x is 8, y is negative 2, lambda is negative 1 over 8. So that is our first point. And the second point is x equals to negative 8, y equals to 2, and lambda equals to 1 over 8. Yes, that's our point. Okay, so now let us determine which one is maximum point and which one is minimum point. Okay, so how to determine these points is by finding the value. Okay, so let us substitute our point into the function f, right? Okay, what is our function f? Our function f is, let me write down the function f again. So our function f is 2x minus y minus 1. So at the point 8, negative 2, negative 1 over 8, our f, substitute the value 8 and negative 2, is 2 times 8 minus with negative 2 is, no, sorry, minus 1, another one is, and we have positive 17, okay, and we have another point at the point negative 8 to 1 over 8, and our function negative 8 2 equals 2, so 2 times negative 8 minus 2 minus 1 is equals to negative 19. So if we can see here, our 17 is, of course, is greater than negative 19. So from this statement, we know that the maximum value is $17, and the minimum value is negative 19. So we have the point 8, negative 2, negative 1 over 18 is a maximum point, and the point negative 8 to 1 over 8 is a minimum point. So that's it.